Hello everyone, I am Dr. M.V.N. Chakravarti. So, the subject which we are discussing now is signals and systems, which is one of the important subjects in the GATE exam. So, you are going to get almost 15 to 20% of the questions in the GATE exam. So, today we will see introduction to signals and systems. Okay, so first of all, let us try to understand what is a signal. What is a signal? So signal is any quantity which is conveying certain amount of information. Let us say I'm generating a speech signal. I am speaking now. I am generating a speech signal, and from that signal you are getting some information. Okay, so you are trying to understand some concept. So signal is any quantity which is conveying certain amount of information. Okay. So the definition of a signal can be given as signal is any quantity conveying certain amount of information. Certain amount of information. Okay. Or there is some alternate definition for a signal. So signal is any quantity which is varying with one or more independent variables. That is, let us say I am speaking now, I am generating a speech signal. This speech signal keeps on changing with time. It is not fixed. Okay, the amplitude of the whatever signal which I am generating, it keeps on varying. Sometimes it may be high, sometimes it may be low, or at some time there is no signal at all. The amplitude is zero. So the amplitude of the signal keeps on changing with respect to time. So the alternate definition for a signal can be given as signal is any quantity which is varying with one or more independent variables. Okay. So just now I told you that speech signal, it is varying with time. So time is an independent variable. Okay. So the alternate definition for a signal is signal is any quantity. Signal is any quantity which varies with one or more independent variables. One or more independent variables. Okay. So let us try to understand the definition of a signal with a few more examples. Okay. So let us see other examples. Just now I told you speech signal. Speech signal. So speech signal is having certain amount of information according to this definition. At the same time, the speech signal is continuously varying with respect to time. Its amplitude keeps on changing. Okay, that is one example for a speech signal. So other signals like a image signal. Image is also a signal. Okay. So whatever image which you are seeing, it is also a signal. It is giving you certain information. Or video signal, or let us say the temperature of a room. Okay, let us say room temperature. and so on, etc. These are the different examples for signals. Okay. So all these signals having certain information. Speech signal is giving you certain information. Image. When you look at an image, you can, let us say, you can identify what is that image, what that image consisting of, what are the objects in that image, or what are the persons which are there in that image. Like that, you have certain information. Or video signal, you are looking at, you are watching movies, it is a video signal. That also is having certain amount of information. The temperature, let us say the room temperature, how the temperature is changing. Let us say I am measuring the room temperature with some thermometer, it keeps on changing. Okay, so the temperature in the morning may be less, in the afternoon the temperature is more, and once again in the evening the temperature falls down, and so on. So it is also giving you certain amount of information. So according to the first definition, that is, all these quantities are conveying certain amount of information. Okay, and at the same time, according to the second definition, all these quantities are varying with respect to one or more independent variables. For example, if I take speech signal, and if I have a notation of S, for example, I am using letter S for the speech signal, it is varying with respect to time. So it is a function of time. Time is an independent variable, so it keeps on changing with respect to time. Or if I take image signal, image is nothing but just a picture. Let us say you are looking at some picture in your mobile. Let us say this is your mobile screen. This is your mobile screen, and you are having certain image, like let us say some image of some person or some whatever it may be. So in that image, the intensity of the picture or intensity of any point is different at different locations. Or if it is a color image, the color of the the color of the point keeps on changing from one point to another point. Okay, the color is maybe at some point it is red, at some point it is green, and so on. So this image keeps on changing with respect to two variables. Let us take this image, let us say this is your mobile phone screen. It is a two-dimensional one, so it is having two axes. So what are the two axes? X and Y, let us say. So with respect to X and Y coordinates, with respect to, let us say this one is X1, Y1. So with respect to X1, Y1, this is the point which is having certain color. If it is a color image, at this point it may be some other, let us say this is my x2 and y2, this is having some other color. Or if it is a black and white picture, then its color may be white or black, and so on. Okay, the intensity of the point keeps on changing. So my image here is, if I represent my image, or if I denote my image with capital I, it is a function of two variables. What are the two variables? X and Y. Okay, so these are the two independent variables with respect to which my image signal is changing. Or if it is a video signal, let us say I represent the video signal with capital V. Now video signal is also seen on a mobile phone screen, but the signal is additionally changing with respect to time also. Unlike your image or picture, it is constant always. Okay, it is not moving. Okay, so it is not changing with respect to time. But if you take video signal, the picture keeps on changing, isn't it? So it is not only changing with respect to x and y axis, it is also changing with respect to third independent variable, which is time. Okay, so if I represent my video signal, or if I denote my video signal with V, capital V, it is a function of x, it is a function of y, as well as it is a function of the third independent variable, time. So it is a function of three independent variables. Now if you take room temperature, so it is also changing with respect to time. Okay, let us say I am taking the temperature at this point of time. Maybe after 1 hour the temperature is different. Okay, so after 2 hours the temperature may be different. So it keeps on changing with respect to time. At the same time, let us say in this room I am measuring temperature at different points. Okay, at this corner I am measuring the temperature, or at that corner I am measuring the temperature, or at this point I'm measuring the temperature. There may be a slight difference in the temperatures, okay, depending upon the ventilation and so on. So the temperature here is changing with respect to the three coordinates x, y, z, because the point in any room, which is a three-dimensional space, so it is a function of three variables x, y, z, because it is a three dimensions. So the temperature is changing with respect to x, y, z. That is, the temperature at different points of the room is different. At the same time, it is also changing with respect to time. Let us say if I take temperature at this point, and this point temperature is changing with respect to time. Okay, so it keeps on changing with respect to another independent variable, time, given by small t. So these are this is the definition of a signal. Okay, so according to the first definition, that is, all these signals or all these quantities are conveying certain amount of information, or according to this definition, all these quantities are changing with respect to one or more independent variables. Okay, so this is what is the definition of a signal. Now that you understood what is a signal with the help of some examples, let us try to understand what is a system. Okay, so system is the one which is operating on the signal. Okay, let us say I am giving some signal as the input to the system. The system is performing some operations on the signal, and it is generating some another signal, which is the output signal. Okay, so in a system, the signals are being operated. So signals are operated. Signals are operated by a system. So we'll try to understand what operations the system is performing on signals in the subsequent topics. Now, let us try to understand the system with the help of some example. So, let us say I am having a communication system. Communication system. So, what is a communication system doing? It is transmitting some information from one location to another location. Okay. So, in a communication system, usually you have a transmitter, you have a channel, then receiver. So, transmitter is the one which is converting different signals like audio signal, video signal into electromagnetic waves, or it is modulating some carrier signal, and it is transmitting that modulated signal through a channel. Okay, so from the channel it is received by the receiver, and the receiver is once again demodulating into useful information. Okay, so a communication system is basically having three major building blocks. That is, the first one is the transmitter. Then we have a channel. Then we have a receiver. Okay, these are the three elements of a communication system. Okay. So what is the input to the system? Some information. Okay. Information means it may be some audio or video or whatever may be the information. So information signal, maybe a video signal or audio signal or some file text we are transmitting through this communication system. Okay. Now the what is happening here? My transmitter is actually converting this signal into some electromagnetic wave, which is being propagated through a cable, or it is propagating through air if it is a wireless communication system. So my channel here may be a cable or it is air. Okay. Sometimes if it is an OFC, that is optical fiber communication, so at the transmitting end, the signal is converted into light pulses. So the light is being transmitted through the channel. So in that case, the channel is a optical fiber cable. Okay. So from the channel, the signal is reaching the receiver, and at the receiving end, it is demodulating. So here we call it as modulating, converting my signal into some electromagnetic wave or modulating my electromagnetic wave, which is also known as the carrier wave. That is what is modulating. So it is being demodulated the receiver and it is converted to some useful information. Okay. So the finally my signal is coming out of the communication system. Okay. So whatever information which I am transmitting, the same information I am getting back at the receiving end. But sometimes what may happen is or usually what will happen is along with the original information there is some noise being added. Okay. During transmission, uh, the noise is being added to the signal. Okay. So we can say the received information is noisy. Okay. Noisy information. So these three building blocks, or these three together, forms a system. So this is my system now. So what is my system doing? It is taking some signal as the input, it is performing some operations, and it is generating some output signal. Okay. So noisy information signal. So this is an example for a system. Okay. So this is my overall system. My system may have some components or some subsystems. You can call this transmitter, channel, and receiver as subsystems of the overall system. Okay. This is some example. So that we can give additional examples like scientific instruments. Scientific instrument is also a system. So what is my scientific instrument doing? It is measuring certain parameter like temperature or humidity or pressure and so on, and it is converting that parameter into some voltage signal or current signal. So that is also a system. Okay, scientific instruments used for measuring parameters like temperature or humidity or pressure, etc. is an example for a system. Or in industries or in plants, we have process control systems. Process control system. What is a process control system? It is controlling certain parameter. That is, I want to control the temperature of a boiler. So it is a system and it is measuring temperature and it is trying to maintain the temperature at some desired value or set point. So it is also performing some operations on the signal, okay, temperature signal, let us say. So it is a example for a system. Or avionics in aeroplanes is an example for a system. We have number of systems in the aeroplanes, okay. Then we have automobiles. In automobiles also, it is there are number of systems which are controlling certain parameters, okay. Now human body is also an example for a system. So human body itself is a system. It is taking some input signal and it is generating some response. So a simple example which I can give you is somebody is asking your name. So what is your name? Okay. So you are getting some audio signal, okay, or you are getting some speech signal, and you are through your ears you are able to understand what he is saying. He is asking for your name, and you are responding. You are generating some output. My name is Chakravarti, let us say. So I have some input signal which is audio signal, and audio signal asking for your name. Somebody is asking for your name. What is your name? And what is your system is generating some output. Okay, so through your mouth you are generating output. My name is Chakravarti. So it is taking some input and it is generating some output. So my human body itself is a system.